Now, hopefully you can remember that we had a look at hydrocarbons known as alkanes. And the alkanes are saturated hydrocarbons. And if you'll remember, I explained what saturated means in this sense. So saturated means that every carbon in the hydrocarbon is bound to as many other atoms as possible. And in practice, that means that there are no double bonds within the molecule. So, for example, ethane, which is C2H6, looks something like this. So every carbon in there, so there are only two, but every carbon is singly bound to other atoms. So carbon is bound to carbon, and each carbon is also bound to 3 hydrogens. Okay? Because there are no double bonds, and a double bond would look like this. This would be a double bond. Because there aren't any of those, then we can say that this is saturated. It is a saturated hydrocarbon. There we go. But what would an unsaturated hydrocarbon look like? Now, we just mentioned that an unsaturated hydrocarbon would have double bonds, because a saturated one does not. It doesn't matter how many of these double bonds this hydrocarbon has. If it has one or more, then it is not saturated, because saturated means completely free of those double bonds. In comparison to ethane, ethene would look like this. The reason being, you'll remember that each carbon has the ability to bind to 4 other atoms, or make 4 other bonds. So here, each carbon is doubly bound to the other carbon. This really means 2 bonds, so each one of these lines is a bond. And so if each carbon can only have 4, each carbon here can only have 2 more. So 1, 2, 1, 2, and we get ethene, which has the formula C2H4. 2 carbons, 4 hydrogens. Now we call this type of hydrocarbon an alkene. So an alkene instead of an alkane. And you'll see this pattern because this molecule is known as ethene. So alkene, ethene. Whereas if we go up here, this is ethane. And you can see ethane, alkane. So the ending dictates how we pronounce the compound and tells us whether it's an alkane or an alkene. If I said to you that I had pentene, you would know immediately that it is an alkene because it ends in ene. If I had pentane, you would know immediately that that molecule is an alkane. Okay, so as we did with the alkanes, let's have a look to see if we can find a pattern. I'm going to draw the next one for you. If we have propene in this case, it's going to look like this. Now we only have one carbon-carbon double bond. In reality, you can have molecules with more than one double bond, but for simplicity, we only ever look at ones with a single double bond at the moment. So each carbon has 4 bonds. So 1, 2, 3, 4, because they're double bond. 1, 2, 3. This middle carbon can only bind to 1 hydrogen because it's bound doubly to a carbon, plus another bond to the other carbon. And then this final carbon can bind to 3 hydrogens because it's not double bound to anything. And so count the carbons, we have 3 carbons, and count the hydrogens, 1, 2, 3, 4, 5, 6. So C3H6. This is starting to look like a pretty simple pattern, but let's have a look at one more. Butene has 4 carbons, and remember I'm only going to draw 1 double bond, and so every other carbon has to have 4 bonds. So it'll look like this. 2 hydrogens bound to the last carbon, 1 hydrogen here because we have a double bond and a single bond, and then 2 hydrogens here because we are bound singly to 2 other carbons, and then 3 hydrogens on the end. So let's count. We have C4, and how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. H8. And so butene, propene, and ethene they all have a very obvious pattern. C2H4, C3H6, C4H8. You can see that for the amount of carbons there are, which we call the number N, each time we have double the amount of hydrogens. And we don't have to add any more hydrogens on or take away, it is literally just double the amount of carbon. So we call that CnH2n, which is double N. Okay, now the last thing I want to show you is that there is a test that we can use to differentiate between an alkane and an alkene. So let's pretend we have two beakers containing two separate substances, call them A and B, and we want to find out whether A and B are alkanes or alkenes. Now it's important here that I've drawn them as liquids. This will work exactly the same if they were gases, but obviously the equipment would have to be different. We'd have to bubble the gas through or use a test tube with a stopper on the top. Now what I'm going to do is I'm going to add a substance called bromine water, which is literally bromine in water. Surprise, surprise. And bromine water is actually orange. So we've got our bromine water in here. Now if I add the bromine water, okay, into here, and the solution turns orange, then that tells us that A is an alkane. It could be other things, but in this example we're saying that it's definitely going to be an alkane or an alkene. And so A is therefore an alkane. A is an alkane. If we carry out the exact same test with B, so we have our bromine water and we pour it into B, what happens here is that we don't actually get a colour change. So you pour the orange liquid in, which is the bromine water, and that bromine water then loses its colour and just stays as it is, so completely clear and colourless. If that happens, then in the beaker, out of alkane or alkene, we have an alkene. So an alkane will not change the colour of bromine water, it will stay orange, whereas an alkene will turn the bromine water from orange to colourless. That means that a reaction has happened between the alkene and bromine water, but in the case of an alkane, it will not react with the bromine water, hence why we still have exactly the same colour on left. Okay, so I'll stop there. I hope that's been helpful. If you do have any questions, then please do put them in the comments below, but I'll see you in the next video.